Describe the pattern for the following sequences, hence complete the sequences. Okay, so we go to part A. So first we need to find out the patterns of this number sequence first. Okay, from here I know this is plus 3, right? Plus 3. So I guess that here should be plus 3 also. So 8 plus 3 you get 11. 11 plus 3 you get 14. Okay, correct. 14 plus 3 you get 17. 17 plus 3 you get 20. Okay, so if the questions asks us to describe the patterns, then it will be add 3 to the previous numbers, or you can say previous terms. Previous number. Okay, let's go to the part B. Okay, so here is minus 2. So we try minus 2, see we can get the correct answer or not. 8 minus 2 you get 6. Okay, then 6 minus 2 you get 4. Okay, correct. 4 minus 2 you get 2. 2 minus 2 you get, okay, here you minus 2 you get 0. Okay, so 0 minus 2 you get negative 2, so no problem. Okay, so this is subtract 2 from the previous number. Okay, so how about C? This one, if this is, let's say, plus 2, here is plus 6. I think this is not the correct way, so let's try another thing, another method. So maybe with times we use multiply 3. Okay, no problem. Here multiply 3. Wow, correct. 3 times 3 you get 9. So 9 times 3 you get 27 times 3. So 27 multiplied by 3 get 81. Okay, no problem. So 81 times 3 you can double check with your calculator. 81 times 3, okay, 243, no problem. And 243 you times 3, you will get 720. Okay, so how to describe this number sequence? It's actually very easy. Multiply the previous number, or you can say previous number by 3. Okay, go to the last one here. 500, 250, 125. From here you know this is actually divided by 2, right? Divided by 2. So here divided by 2. Okay, you just press the calculator. 125 divided by 2. Okay, 125 divided by 2, you should be able to get 62.5. So we need to double check. Maybe this answer is not correct. So we divided by 2. We get 31.25 and divided by 2 again. If we can get this number, means that our answer, no problem. 31.25 divided by 2. Okay, 15.625. Okay, correct. So how to describe it? Divide the previous number by 2. Okay, so these are 4 basic methods. How do we describe a number sequence? In this chapter, you also learn about the Pascal triangle and Fibonacci numbers. Okay, let's go to this Pascal triangle first. You have a diagram like this, and the questions will ask you to fill in the missing number. So how do we get this number? It's actually very easy. So this is Pascal triangle. You always start with 1 and end with 1. So you see 1, 2, 1. So how do we get 2 here? 2 is actually 1 plus 1, you get 2, right? So this number is actually 1 plus 3, 1 plus 2, you get 3. So here the same thing, 2 plus 1, you get 3. Okay, how to get this number? Very easy. 1 plus 3, you get 4. You see, always start with 1 and end with 1, right? Every row, same thing, 1, 1, 1, 1. Okay, so how to get this number? 3 plus 3, you get 6. Okay, then this number, 3 plus 1, you get 4. Okay, if the questions want you to continue one more row, it will be like this. 1, 1, right? So 4 plus 1, you get 5 here. 4 plus 6, you get 10. 6 plus 4, you get 10. 4 plus 1, you get 5. Okay, so this one we call it Pascal triangle. Another one is a Fibonacci numbers. So Fibonacci number. So Fibonacci numbers means that the next term is actually the sum of the two previous terms. So you see, 1 plus 1, you get 2, right? So 1 plus 2, you get 3. 2 plus 3, you will get 5. And 3 plus 5, you get 8. 5 plus 8, you get 13. 13 plus 8, you get 21. Okay, so these are another two patterns you are going to learn in these chapters. Next, I want to introduce to you Tn and Sn. Tn and Sn. Okay, for instance, let's say you have a number sequence 2, 4, 6, 8, 10, and so on. Okay, so here is the first terms of this number sequence. We can call it T1. So this is a third term, right? Third term, we call it T3. So this is 1, 2, 3, 4, 5. This is fifth term, we call it T5. So how about Sn? So S3, let's say S2 is equal to T1 plus T2. Means that Sn is the sum of the first term to the n terms. So S2 is the sum of the first term to the second terms. S3, the sum of the first term to the third term. T3 and so on. So here we have a few concepts that you need to know, so it will be easier for you to solve the questions. T1 is actually equal to S1. Okay, you see, T1 is 2, right? S1, 2 also. And Tn is actually equal to Sn minus Sn minus 1. What does this mean? Okay, let me show you here. Let's say I just write, okay, let's say we want to find T3. According to this formula, this is S3 minus S3 minus 1, right? So it will be S3 minus S2. Okay, so why like this? So S3 is T1 plus T2 plus T3. And S2 is T1 plus T2. When you take this one minus this one, it will cancel out the T1 and also the T2. So eventually you will only have T3. Okay, so remember these two concepts, so will be very helpful when you solve the question for this number sequence. Describe the pattern for the number sequence by using numbers, words, and algebraic expression. Okay, so we have a number sequence here. So we need to describe it using three ways: numbers, words, and algebraic expression. Okay, we go to number first. So from here, actually, you know this is plus 4, right? So plus 4, keep on adding 4 to the previous term. So if you want to describe it by number, very easy, plus 4. Pattern is plus 4. So how about words? Words, add 4 to the previous number. or you can say previous term. So by using words means that we have to make a sentence. So how about C, algebraic expression? Okay, so this one I think I will just start by drawing a table first. Draw a table like this. Okay, here's n, here's Tn. So first term, second term, third term, fourth term, and so on. Okay, and then we go to n terms. Okay, the first term we know that this is actually 3, right? So here is 3, second term is 7, 11, and 15. Okay, from here we need to take a guess. Actually, we have some formula to help us to get the patterns. But in this chapter, in this video, I will not using the formula. Okay, so how to get the pattern? We need to take a guess. So 3. So you have to change the way of writing the 3, but you still need to keep the same value 3. So from here, actually, I know this is maybe I write over here first. Maybe I write, okay, 4 times 1 minus 1. Okay, 4 times 1 minus 1, you get 3. Okay, correct. So these are second terms. Okay, 4 times 2 minus 1, correct or not? Okay, you get 7, right? So how about this one? 4 times 3 minus 1, you get 11. Okay, try another one. 4 times 4 minus 1. Okay, you get 15. So when go to n, definitely will be 4 times n minus 1, right? So from here we can make a conclusion that Tn is actually equal to 4 times n minus 1, where n is equal to 1, 2, 3, and so on. Okay. Make a generalizations about n terms for each of the following sequences by using algebraic expressions. Okay, so from here, like just now, I draw a table first. I draw a table. So this is n, this is Tn, right? Okay, so this is first term, second term, third term, and so on. Okay, I go on to number 4. Until we go to the n terms. So this is our first term 3, second term 6, 9, 12. Okay, like just now I told you, we need to change the way of writing the 3, and we need to find out the trend, the patterns of this number sequence. Okay, so here I can write the 3, right? I can write 3 times 1. Still the same thing. I can change the way of writing the 3, but I cannot change the value. So how about 6? 3 times 2, right? So this is 3 times 3. This is 3 times 4. So from here, notice that when n is equal to 1, first term, here is 1. When n is equal to 2, second term, here's 2. When n is equal to 3, here's 3. So from here, we can make a conclusion that when n is equal to n, definitely it will be 3n, right? So from here, we can make the generalizations. Tn is equal to 3n, where n is equal to 1, 2, 3, and so on. Okay, and the question also asks us to find the terms number 10 and 18. So since we know Tn is equal to 3n, T10 will be equal to 3 times 10, which is equal to 30. T18 will be equal to 3 times 18. Okay, this one you can just press the calculator. 54. Okay, let's go to the part B, second one. So here 3, 5, 7, 9, and 11. Same thing, I draw a table first. This is optional. Actually, if you don't want to draw a table, also can. No problem. As long as you can get the patterns of this number sequence. So n, this is Tn. So number 1, term number 2, term number 3, number 4, and so on. Okay, and the term number, the n term. So number first term, T1 is equal to 3, T2 5, 7, 9, and so on. Okay, same thing. I want to change the way of writing a 3, 5, 7, and that can let me see the trend. So how to write the 3 here? So maybe I write 4 minus 1, you get 3. Okay, so this is the first term, I minus 1 first term. Okay, second term, 4 minus 2, 3, but this is 5. Oh, not correct. This pattern is not correct, so I have to change the way of writing it. So maybe this one I write 2 times 1 plus 1. Okay, you will get 3, right? How about 2? Okay, second term, 2 times 3. 2 times 2 plus 1. You get 5. Oh, correct. How about this one? 2 times 3 plus 1. Okay, correct. 2 times 4 plus 1. Okay, correct. So when go to n terms, it definitely must be 2n plus 1. Right. So from here, we can make a conclusion. Tn is equal to 2n plus 1, where n is equal to 1, 2, 3, and so on. Okay, so don't forget the questions asked to find T10. 2 times 10 plus 1. So this is 20 plus 1, 21. Okay, T18, 2 times 18 plus 1. So 2 times 18, you get 36, plus 1, you get 37. Okay, so we have done these questions. Given the sum from the first term to the n terms of a number sequence is this. Okay, so from here we know as n is actually equal to 2n squared minus n, right? So find the first term. We want to find the first term, which is t1, and the third term, which is t3. Okay, just now you remember t1 is equal to s1, right? So t1, the first term, must be equal to s1. 2 times 1 is squared minus 1. Okay, so this is 2 minus 1, you get 1. So the first term is 1. So how about the third term? How about the third term? So remember this. Tn is equal to Sn minus Sn minus 1, right? So T3 is equal to S3 minus S3 minus 1. So it's equal to S3 minus S2. Okay, so S3 use this formula. 2 times 3 squared minus 3. Okay, this is for S3. Okay, now we go to S2. We're going to make right here 2 times 2 squared here minus 2. Okay, so this is 18. 18 minus 3, you get 15. Okay, this one you get 6. So 15 minus 6, you get 9. Okay, so this is the third terms. Okay, for this video, I'll just stop here. See you in the next video. Bye bye.